Hello, Algebra 2. We're going to finish up the 2.2 slope of the line. I'm just going to go through the whole notes. So first of all, you all should have made this adjustment already, but this hashtag should be a triangle, right? And a triangle right there. That really is signifying the change in y over the change in x. Okay, so right here we looked at going from this point, okay, to this point and talking about the slope. So what we talked about with slope there was rise 1, 2 over run 1, 2, 3 as we went over here. Okay, that was the change from this coordinate, which we can call x1, y1, which is at 0, 1, right, being x1, y1, to the coordinate right here, which is at 3, 3, right, and we'll call that one x2, y2, okay? So what we've done basically is gone the change in y, which was 2, okay, 1, 2, over the change in x, which is 3. Okay, so that gives us a slope, which is usually signified by the variable m, okay, and it's rise 2 over 3. Okay, now something that we pointed out in class as well is if I go from this point right here to this point, going down and back, I would get a negative 2 over a negative 3. Negative 2 rise, negative 3 run. And that would be the same as a positive 2 over positive 3. Let's just show that real quick. Right? A negative over negative equals a positive. Okay, so the slope's going to stay the same no matter which direction you go as you're going from one point to the next. Okay. Move into here. We talked about slope being defined as rise over run. So we're taking a look at a horizontal line. Going from here, a rise of 0, a run of 1. Gave us the slope of rise 0, run 1. The slope equals 0. Here, a vertical line, we're talking about our rise of 1 and a run of 0. So it's the reciprocal. We've got 1 over 0. Now that's a problem right there. We cannot divide by 0. It is undefined. So this would be, let's see if we can do this, our undefined slope right here. And we can just call that UD for undefined. Okay? Right here, this is a positive slope. As you can see, we're going up as we move on the x-axis from left to right. We're moving up. Okay, so that's always going to be a positive slope. And we can just take 2 points and figure out what the positive slope is. Rise 1, run 1. So that would be a 1 over 1 or a slope of 1 and positive 1. Okay, the next one here, we see this slope heading down as we go left to right. It's heading down. Okay, so that is going to be a negative slope. And what I want to do is go from 2 points that I'm pretty sure are integers right there to this point right here. Okay, and that's a rise of negative 1, 2, 3, 4, and a run of positive 1, 2, 3. So I had a negative 4 over positive 3. Okay, so that's my slope is a negative 4/3. Okay, again, if I'm going up as I'm going left to right, it's going to be a positive slope. If I'm going down as I go left to right, it will be a negative slope. Okay, with the vertical lines, it's undefined. With a horizontal line, right, it's just a slope of 0, which is neither positive nor negative. All right, moving on here. Something I like to do with this, we're looking at the equation, right, of slope, which is m equals y2 minus y1 over x2 minus x1, okay, to find the slope. That is, when we're given 2 points, okay, we use this equation to find the slope. So what I like to do is above my coordinates here, I'm going to call this one x1, this one y1, this one x2, this one y2. Okay, and I just plug it into the equation. M equals 2 minus 5 over 4 minus 3. So I get negative 3 over 1, so that is negative 3. Okay, let's do that over here. X1, Y1, X2, Y2. So M equals 6 minus 4 over 5 minus a negative 1. Okay, be careful with these negatives here, okay, because it's going to change to be positive. But we take a look at this. 6 minus 4 is 2, okay, and 5 minus a negative 1 is the same as 5 plus 1. Okay, so that would be over 6. And then we reduce this to be a slope of 1/3. Okay, so that is part of the lesson where we're given 2 points and we're asked to find the slope. Okay, given 2 points, asked to find the slope. Now we look at the next one. We're given an equation of a line, a linear equation. That is where a y and an x are in the equation. They're both to the first power. Okay, that's the definition of a linear equation. All right, so let's take a look at this. How do we get the slope out of this one? Well, we put these into y equals mx plus b, where m is our slope. Okay, so we basically solve for y and then take the coefficient, the number in front of x, and that is our slope. Okay, so let's take a look at this one. I've got the 3x plus y equals 1. So I want to isolate this y. So I'm going to subtract 3x from both sides. Subtract 3x. And I always like to put the x first after my equal sign. So I've got y equals negative 3x plus 1. And my slope is going to be this number right here. So the slope here, m equals negative 3. Okay. For the next one, I'm going to switch back to blue. I like writing in blue better. I need to isolate y. Okay, I need to isolate this y. So the first move I'm going to make is subtract the 3x over. Subtract 3x. Now I've got negative 2y equals negative 3x plus 8. Okay. Now I'm going to divide through by negative 2, and I have to divide everything through by negative 2. Okay, so I get y equals negative 3 over 2 is positive 3/2, x, and then minus 4. Okay, so again, my slope is going to be the coefficient of my x when y is isolated. Okay, so it is positive m equals positive 3/2. All right, very good. Let's keep moving here. Oh, that's it. Okay, so what have we done? We've looked at when we're given an equation of a line, how do we find the slope? Solve for y. Okay, and then the coefficient of x, the number in front of x, is our slope. We've looked at given 2 points on an xy coordinate plane, how do we find the slope? Well, we plug it into this slope formula, y2 minus y1 over x2 minus x1, and we reduce that and we get our slope. And then we've also looked at in a graph, how do we find slope? Well, we just count out rise over run to the next point, and there we go. That's our slope. All right, very good. Have a good rest of your day.